Okay, good morning to all. Myself Vinanjan Patnaik. Welcome to the today's lecture about the mobile computing. Chapter 4 is the medium access control. So let's look. The first is your medium access control. So what is the MAC, medium access control? Now in wireless network, multiple terminals need to communicate at the same time, and a medium access control MAC protocol allows several terminals to transmit over the wireless channel and to share its capacity. And MAC protocols multiplex several data streams of different terminals to share the same channel and deal with issues such as addressing, how a terminal obtains a channel when it needs one, and so forth. That means this one wireless network, the multiple terminals need to communicate at the same time, because in wireless network the number of the terminals is communicating with each other. So definitely there is a protocol which control these traffics among these terminals. So MAC is a protocol which controls this type of traffic in this type of communications. So MAC schemes can be divided into two categories here. One is your connection free and another is your connection based protocol. So in a connection free MAC protocol requires a central controller to coordinate the resource allocation, and the central controller can be base station in a cellular network or an access point in a wireless local area network. So MAC are two types. One is a connection free and connection based. So in the connection based, there is infrastructure is there, and you can control the entire traffic system. But in case of the connection free, MAC protocol requires central controller to coordinate the resource allocation, and the central controller can be a base station in a cellular network, an access point in a wireless local area network. So that controller may be a base station, may be a access point, whatever the point which control the entire traffic. So MAC is nothing, it is a protocol which control the entire traffic during the communication in wireless network. That's simple. Next, the concept is known as the hidden terminals. Is another terminal concept is here used. In the above diagram shows that station A, what is the hidden terminal? That means a terminal which is hidden from the range of the another device. So here look the picture that station A starts transmitting to station B, right? Since station C is out of radio range of A, it perceives that the channel is free and starts transmitting to B. The frames received by C are garbled and collision occurs, and this situation is known as the hidden terminal problem. So let's analyze on this figure. Here the node A, that means the range of this dotted line is the range of this A, device A, and this dotted line is the range of the C. And B is the device, B is a node to which the node A is transmitting the data, and the same time node C and the node C also transmitting the data. Then what will happen? Suppose look this range of the A, which is the, and this range of the C. Problem is that range of A is not coming under C, and range of C is not coming under A. So range A or node A is totally far away to know the range of the C right now, and C also the out of range of the A. That means when A sends the data to the B, though C is out of range of the A, that means C assume that now the connection, the B has no transmitting or occurs to the B. So what will happen? C now ready to transmit the data to the B, because A is transmitting, but though the range of the A is not coming under the C, so C, there is no possible to know that whether A is transmitting the data to the B or not right now. So the C assume that B is free, but in the same time A is transmitting the data. Due to this range problem, this C is now hidden for A, and A is now hidden for C. So that is the hidden. So what will happen? At the same way, C assume that B is free and A assume that B is free. So that same time C is transmitting the data to the B and A is also transmitting the data to the B. So what will happen? There is a collision occurs and data will be lost. So that is the problem in case of the hidden terminals problem. Next is your exposed terminal. In wireless network, the exposed node problem occurs when a node is prevented from sending packets to other nodes because of co-channel interferences with a neighboring transmitter. So here exposed terminal, that means is another problem like hidden terminal. Consider an example of 4 nodes level R1, S1, S2 and R2, where the two receiver, here R1 and R2 are two receiver, R1 receiver and out of range of each other, and here the two transmitter S1, S2 in the middle range of each other, right? Here if a transmission, then what will happen? Look the figure. This R1 is the receiver, R2 is the receiver. Look, this is the color of the maroon color, this is the color of the green color. What will happen? The range of the R1 and the R2 is totally idle, or the range R2 is not coming under the range of R1, and simultaneously R also is not coming under the range of the R2. Next what happened? The two transmitter S1 and S2. S1 transmit data R1 and S2 also transmit data to R2. In the middle are range of each other. Here if a transmission between S1 and R1 is taking place, node S2 is prevented from transmitting to R2, and it concludes after carrier sense that it will interfere with the transmission by its neighbor S1. However, note that R2 could still receive the transmission of S2 without interference because it is out of range of S1. That means here the S1, S2 the two transmitter, but here range is that S1 is coming under the S2 and under the range of the S2, and S2 is also coming under the S1. But the problem here, though two receivers is out of range, that means it is not coming under R2 and R2 is not coming under R1. Now what will happen? Now suppose S1 is sending to the data R1. Clear? S1 sending the data R1 and S2 is prevented from transmitting to R2. R2 as it concludes after carrier sense that it will interference with transmitter is neighboring S1. That means though the two transmitters is coming under one range, or S1 is coming under S2 range and S2 is coming under S1 range, and what will happen? When S1 transmit the data to R1, that means though S2 is coming under S1, so S2 assume that S1 will send the data to the R2. But here the actual case is S1 is sending the data to R1. But though the two object, that means these two transmitter is coming under one range, that means S1 is coming under S2 and S2 is coming under S1. And problem that both R1 and R2 is totally idle from the R2 is idle from S1 and R1 is idle from the S2. That means R1 and S1, when S1 transmitting the data to R1, but S1 is also the coming under S2. That means S2 assume that S1 transmitting the data to R2. So what will happen? S2 now the S2 though this link between S2 and R2 is free, but S2 still not transmitting the data to R2. Clear? The problem is that what? Again I am repeating. R1 and R2 is out of range. That means R1 not coming under R2 and R2 is not coming under R1. Okay, it's fine. But S1, S2 is coming both range. S1 coming in the S2 range, S2 is coming in the S1 range. So when S1 is transmit the data R1, what will happen? S2 assume that S1 is S2 know that S1 is transmitted data to a receiver. Clear now? But though R1 and R2 is not coming under a single range, that's why S2 assume that S1 transmitting the data to R2. So S2 stops to transmit the data for the collision. Clear now? So, but here actual S2, the link between S2 and R2 is free. So, that is known as the exposed terminal problem. Okay. Next class we are going to discuss another concept. Okay, thank you.